founder at 10x Coder Kids, and an official Guinness record holder for the youngest computer programmer in the world. And today you're gonna be starting with some basics of Solidity. So without any delay, let's get started. Alright. So over here I have opened the remix editor for that is basically used to write Solidity code. Alright. So first of all, you must have seen in many smart contracts or Solidity codes that you must have seen like this comment on the top, SPDX license identifier and maybe some value, let's say MIT. So I'm pretty sure you must have seen this as the first line of many Solidity codes. If you haven't, let me explain it. So you must be wondering what this actually means, right? So this is basically always our first line of our code. Basically this tells that a code is under which license. So over here I have set the SPDX license identifier as MIT, right? So MIT is the license and our code that we will write, this contract we will write, will be under the MIT license. Right now, who defines these licenses? SPDX is the universal basically service that is used to basically define these licenses, right? And there are many licenses like MIT, that is basically that one of the properties of MIT licenses, that it tells that you have to make your source open, make your code open source, right? So you'll have to make your code open source. That's one of the properties of the MIT license. So you also have the unlicensed license, right? So there is also a license named unlicensed, right? So what does unlicensed mean? It tells that our code won't be open source, right? So through this license we are saying that we don't want our code to be open source and we don't want anybody to use this code, right? And there is one more confusing type of license name, that is unlicensed, right? So unlicensed and unlicensed are completely opposites of each other. Unlicensed, as I told, is a license where we tell that we don't want our code to be open source and we don't want it to be used by anybody else. But unlicensed, on the other hand, gives full permission to anyone to do anything with your code. So they can change, edit, reuse, they can do anything with your code when you have given the license identifier to be unlicensed, right? So this was a little bit about your first line of the code, right? Alright, so next we are gonna be moving on to pragma, right? So you must have been seeing statements like pragma, solidity, and let's say 0.5.2. Let's remove the second license, right? So you must have seen statements like pragma, solidity, 0.5.2, and you must be wondering, what does this mean? Over here, what pragma is, it defines which version of the Solidity compiler should this code use, right? So over here we are saying that this code should use 0.5.2 version of the compiler to compile the code, right? But it's not that simple, right? Over here, for example, I don't have the 0.5.2 version installed, and for example I have the version 0.5.7. So what this statement actually says is that in the 0.5 point range, so it will be 0.5.0 to 9, basically this range. In this range, it will use the compiler, right? So if I say in this statement, if I say 0.5.2, so what it will see, if I have for example 0.5.7 compiler installed, it will see is that 0.5.7 in between 0.5.0 and 0.5.9. So what this will do, it will check if the installed compiler version is between 0.5.0 and 0.5.9 in this above example. So for example, if I have 0.5.7 installed and I'm saying that use 0.5.2, so this is not strictly saying to use 0.5.2. This is saying that use a compiler between the version 0.5.0 and 0.5.9. But as soon as the 0.6.0 series starts, this won't identify that compiler. So for example, I have no compiler in the 0.5 series and I have a compiler like 0.6.2 installed in my machine. It won't be able to figure out which compiler to use, and it will give out an error, right? Pretty cool. So this is called version pragma. So what this is called version pragma. All right. So now we have another type of pragma. We have something called abicoder pragma. So now you must be wondering what this is, right? So this version pragma was compulsory, right? This abicoder pragma is not compulsory, right? So if you want to give, you give. If you don't want to give, you don't give. So basically you have two versions, V1 and V2 in this abicoder pragma, right? And what is the statement? It is pragma abicoder and then, like for example, V2. All right. Right. So what this statement tells us, right? So now this abicoder pragma, like this version 2, has some specific features that you can use in your Solidity code. For example, to encode or decode arbitrary nested arrays, right? And structures, right? So basically there are some special data types introduced in this abicoder pragma version 2, where like you can have nested arrays or you can have data types like structs, right? Structures, right? There is also advanced safety checks, right? So there are also advanced safety checks in this pragma abicoder v2. So that's why you will use abicoder pragma v2. But by default, abicoder pragma v2 is already in use, so you don't have to give this statement. For example, if you want to use the v1, right? If you want to use the version 1, then you can specify separately that I want to use the abicoder version 1, right? Pretty cool, and I hope I am clear, right? The next, what happens in these pragmas when new versions are released, right? So for example, if I say I have this, for example, here in now in a version pragma, for example, a 0.8 point something is released, right? 0.8.7. So what will happen? So for example, if I have a piece of code, right? Let's just take it very simple, x equals to 0, right? This is not an actual piece of code. We're just interpreting that this is a piece of code, right? So now what will happen? X is equals to 0. For example, in our Solidity compiler 0.5.2, it took equals to as an assignment operator, right? And in 0.8.7, it will take equals to as a comparison operator. I'm just giving you an example. Equals to will never be a comparison operator, right? But I'm just giving you an example. So for example, in 0.8.7, equals to is a comparison operator, and in 0.5.2, equals to is an assignment operator. So what will happen if you want to move from 0.5.2 to 0.8.7, you will see that your code will behave oddly. That is because the code is not deprecated, nothing is changed, right? Your syntax will remain the same, but the meaning of that syntax will change, right? So when I switch compilers, the syntax is the same, you don't need to your code will remain the same, but the meaning of the code, the compiler will interpret different. In 0.8.7, it will interpret that it is a comparison operator, equals to is a comparison operator, and in 0.5.2 it will interpret equals to as an assignment operator. So you just, there's something to keep in mind, that your code will not change, right? The behavior of the code will change. So if you change compilers, you must have from when this number over here changes, it brings breaking changes, means that it basically changes the behavior of particular things, right? Particular codes, right? So you have to keep this in mind, right? That was a small piece of information. Next we are gonna move on to imports, right? So you must have seen statements like import, and then you must have seen a filing, right? So this is basically if you have another Solidity file and you want to bring its contents into this Solidity file. So what you'll say, you'll use the import. I'll just remove this x equals to 0 here. You'll say import, and then you'll say dot slash, so you'll locate the file, and maybe x dot sol, right? So what this will do, this will import x dot sol for us, right? So this will basically bring all the contents of x dot sol in here, right? What you'll have you can also do, you can say import x dot sol as as for example content. So what will happen is that whenever you try to use something that is there in x.sol, for example there is a variable named y, and if you want to use that, you'll say content dot y to use that variable, right? You can also do import all as content from x dot sol, right? So you can also do import all as content from x dot, all right? And finally, how you can import, and like for example you have the y variable in your x dot sol, right? And you also have a y variable over here, like y equals to 0, right? This is all or only an example, right? So if I say import all as content from x.sol, we can use content.y, no problem, right? But you have one more notation, import y from x.sol. Now why I'm importing also, and I already have it, so there is a clash of names. So what I can do, use the as keyword in these brackets. So as y2, I can say import the y variable as y2, right? And I can specify more stuff, like I want like a Saion variable, so I can say Saion. But if a Saion variable already existed, I can say that as some other name, Saion 2, right? So this is very powerful if you want to import specific variables or items from a file, then you use the curly braces notation. But if you have names that are similar to the names in your code, then you can use the as keyword to basically import those variables as different names, right? Finally, we have comments. So you have the classic double slash comments, right? So this will create a comment, and this will be a single line comment. And then you have this slash star comment, that will be a multi-line comment, right? So you can write comments in multi-line, right? Pretty cool. So what we have learned today, we have learned about the first line of our code, that is the spdx license identifier. We have seen three of its values, that are basically MIT, unlicensed, and unlicensed. We have learned about pragma, version pragma, and abicoda pragma. We have also learned about comments, and we have also learned about imports. And this is only scratching the surface. We will go on very deep in the concepts in the further coming videos, right? So stay tuned, and I will see you guys in the next video. Till then, stay safe, stay healthy, and keep watching my videos.